Physical science. We're going to finish up chapter 14 today, so we're just going to go ahead and jump right in with our next three types of simple machines. And our first one is going to be a wedge. And again, for the ideal mechanical advantage, don't worry about again, we're not going to calculate anything, but they just say that a thin wedge of a given length has a greater ideal mechanical advantage than a thick wedge of the same length. So thinner the wedge, the more greater the ideal mechanical advantage is. And what a wedge is it is a V-shaped object whose sides are actually two inclined planes that are sloped toward each other. So a wedge is actually a combination of two inclined planes, and it always has a mechanical advantage greater than one. So our example of a wedge is right here. It's used to drive to actually split wood, if you've ever done this before. So this wedge right here, again, you can see the two inclined planes sloping down towards one another, and the inclined planes are going to force the wood fibers apart as the wedge is driven into the log. So this is a wedge. Again, it's used for splitting wood. As you take the hammer, and strike the top of the wedge, you apply the force up here, and then the force exerted down, and it splits the wood fibers apart. So that is a wedge. That is a very effective simple machine if you ever have to split wood. Then our next one is a screw. That's our next simple machine. And when we talk about mechanical advantage, if the screw has threads that are closer together, they're going to have the greater mechanical advantage. And a screw is actually the combination of an inclined plane that's wrapped around a cylinder. So I think we've all seen a screw and knows what it looks like. And for two screws of the same length, the one whose threads are closer together moves forward less for each turn of the screw. So if you have more threads, again, you're going to move a shorter distance each time it's turned, rather than if your threads are more spread farther out. Again, you're going to have a greater mechanical advantage if you are closer together. So a screw and a wedge, pretty simple, again, very practical, a lot of real-life applications for those. And then our last one, again, you've probably seen a wedge and a screw probably in everyday life quite a bit. So our next one is a pulley, and when we talk about mechanical advantage of a pulley, it's going to have to do with the number of rope sections, so that is actually supporting the load that is being lifted, and that will make more sense here momentarily. So a pulley is a simple machine that consists of a rope that fits into a groove and a wheel. I think we've probably all seen a pulley before, and they produce an output force that is different in size, or different in direction, or different in both from that of the input force. So it transforms the force that you put into it. It changes its size, changes its direction, or it can change both. And it either can have a mechanical advantage that is equal to or greater than 1. So if you don't know what a pulley is, then again, welcome to life here. Here's a pulley right here. They're using the pulley to move this large part throughout a factory. Again, you can see the ropes fitting through the groove right here, and then allowing it to support, again, a very heavy piece of equipment there. So we have three different ways that pulleys can be used. Our first one is a fixed pulley, and a fixed pulley is a wheel attached in a fixed location. The direction of the exerted force is changed by a fixed pulley, but the size of the force is not, and so it has a mechanical advantage is always 1. So what it means by the direction of the force is changed, but the size of the force is not. So right here, we are wanting to lift a block that is exerting a force of 4 newtons downward. So we, over here on the rope, we pull the force downward as well. So you would think if the force is acting downward here and we're pulling downward here, then, well, we're just going to make it go down into the ground. However, since we have it attached to a rope, we change the direction of our force. So we put 4 newtons down here, but our pulley changes it to 4 newtons up, so now we are able to raise our 4 newton block up in the air. So it changes the direction of the force. So we initially pull it down, that's our input force, but the input force that is actually moving the block is moving upward. So that's what it means when it says it changes only direction of the input force. So if it changed the size of the force, we could only pull with 2 newtons and move the 4 newton up, but that's not how that works for a fixed pulley. So for our next one we have is a movable pulley. So it is attached to the object being moved rather than a fixed location. So this right here is a movable pulley because you see the pulley is attached to the object that is being moved rather than a fixed location. And both sections of the rope pull up with the same force, and therefore the movable pulley is going to have a mechanical advantage of 2. So here's what a movable pulley looks like. So again, it is attached to our 4 Newton block right here, but now instead of having to exert upward a force of 4 newtons, we have 2 newtons over here, 2 newtons over here, which again, we have now changed both the direction and the size of the input force. So that's our second one, is a movable pulley. And then our last combination we can have is what's known as a pulley system. And a very large mechanical advantage can be achieved by combining fixed and movable pulleys into what's known as a pulley system. So that kind of makes sense that you take multiple pulleys, put them together, and you have a pulley system. And the mechanical advantage depends on how the pulleys are arranged. So there's a lot of different ways you can arrange them. We'll see a picture here in a second. And the ideal mechanical advantage of a pulley system is going to be equal to the number of rope sections supporting the load being lifted. So however many sections of rope you have, that is going to determine, again, like it said, the ideal mechanical advantage is going to be equal to the number of rope sections supporting the load being lifted. So this one has 4 different sections of rope, so it'll probably have an ideal mechanical advantage of 4 for this pulley system right here. So again, we exert the force over here, pulling downward with 1 Newton. And again, the force is spread out over all these different ropes. Because we have 4 different sections, we're able to easily move the 4 Newton block, again, with only exerting 1 Newton of force. So that's how a pulley system works. Again, all these different combinations of rope allow force to be exerted kind of more spread out rather than just on one location, and therefore we're able to apply a very little force to overcome a much bigger force, and that's why we can have a great mechanical advantage when we use a pulley system. And so to wrap up our simple machines, we're going to talk about what is really quickly known as a compound machine, and it is just a combination of 2 or more simple machines that operate together. Most of the machines you use are actually going to be compound machines. We really don't just use simple machines too often on their own. The edges of a pair of scissors are sharpened like wedges, and the blades and the handles together, they function as a lever. So a scissors is a very simple example of a compound machine. Kind of some more advanced versions would be cars, washing machines, and clocks. Those are going to be combinations of hundreds or even thousands of simple machines. So those levers, those pulleys, those wheels and axles, the screw, the wedges, all of those things, just on their own, sometimes, again, they work fine just on their own, but there's a lot of times when we want to do more advanced things that we put them together, and they help us achieve a lot more than just one simple task. And an example would be this watch consists of a series of machines, and the output of one of the machines acts as the driving input for the next machine in the series. So again, there's just one of these gears is pushing another. Again, there's wheels and axles in there, and again, there's probably different screws in there as well. So again, one is just going to drive the other in a compound machine. So that's all they're really going to go into detail with that. So just know simple machines on their own are great, but they kind of serve a bigger purpose to kind of help us make compound machines. So that is going to be it for Chapter 14. Let me know if you have any questions.